Welcome to Mrs. Neller's notes for double block algebra. These are the notes for section 1.6 entitled A Problem Solving Plan. And basically that means that we're going to use algebra models for algebra to help us solve word problems. So our objective today is just that, to use models to solve word problems. Now what we're going to do to actually solve these problems is kind of go through a step-by-step process. Obviously we're going to read the problem carefully. If we need to reread it several times, if we need to say out loud a little description of what is happening, if we need to highlight or circle or box different information, we're going to do all that stuff. We're going to see if there's any formulas that we need to use as well, or if we can kind of put together some sort of equation on our own. And we're going to try and do a verbal model with like little words or phrases, and then we're going to translate that into an algebraic model. So we're using those translating skills that we talked about in the previous lesson. And then we're going to use mental math to solve as well. So we have 7 examples, I believe. And we're going to start off with some easy ones. So example 1 here, this is going to use a formula that we know. So let's read through the problem first. It says that a commercial airplane has been flying for 2 hours. So kind of picture an airplane. If you have or haven't been on an airplane, it's okay, it doesn't matter. Just picture an airplane. It's been flying for 2 hours. And it has gone a distance of 360 miles. How fast has it been flying? So there's a couple key words that you should recognize in here, or some concepts. There's distance, and there's how fast, and then we know 2 hours. So this is basically setting up a distance equals rate times time problem. We know the distance. We want to find how fast it's been going, which is the rate. And then we also know the time, okay? So our verbal model is going to be that distance equals rate times time. Okay. So what we're going to do now that we understand the problem and we can write our verbal model, then we're going to try and translate that into an algebraic model. And we're going to substitute in the information that we know. So the airplane has flown a distance of 360 miles. So I can substitute that in for the distance. We want to know the rate. We want to know how fast it's going. So we're finding R. Okay, I don't know what the rate is. I don't know how fast it's flying. I'm going to put a variable in that spot. But we know it's been flying for 2 hours. So I'm going to put 2 in for the time. And now I can solve this. I can say, okay, what times 2 is 360? Or I could take 360 and divide it by 2, and I will get a rate of 180. And the plane has gone 360 miles in 2 hours, so our rate is going to be miles per hour. So if we wanted to say that in a sentence, we would say the airplane is flying 180 miles per hour. Okay, for example 2, we're going to read a problem about the chess club. The chess club is holding a car wash to raise funds for an upcoming tournament. So kind of picture that in your head. You're on the chess club or any club. It doesn't have to be chess, any club. You're going to plan a car wash. You're going to raise some funds for your group so you can go to different tournaments. Okay. The club wants to raise $500. That's how much they want to get. That's their goal. How many cars are they going to have to wash? That's important. That's what we're finding. How many cars is what we're finding. How many cars will they have to wash if they charge $3 for each car? That's another important piece of information. So we know that the chess club wants to raise $500. We know that they're going to charge $3 per car. So how many cars do they have to wash? That's what we want to find. So I'm going to translate this into a little bit of a verbal model, give it a little bit more structure. Hopefully you're thinking of this already, but basically they're going to take the price that they charge per car. So I'm just going to call that price per car. So that would be our $3 per car. And you would multiply that by the number of cars that you wash. If you're charging $3 per car, you're going to multiply it by how many cars you wash to figure out how much money you've raised, your total amount of money. So there's my verbal model. And I like to put each little part into little boxes or little chunks so I can kind of see it as separate little parts. So now I'm going to substitute in any information that I know so I get my algebraic model. I have $3 per car times the number of cars. I don't know. I'm just going to call that C. I don't know how many cars we're going to have to wash, but I want to raise a total of $500. So now I can solve this. I can think, okay, 3 times what is 500? Or I could do 500 divided by 3. And that's going to be a better approach because we're not going to get a whole number here. We're actually going to get a value of 166.67 when we take 500 and divide it by 3. So they can wash 166 whole cars, and then they have to wash 2/3 of the next car. Now you don't just wash 2/3 of a car. Okay, people aren't going to come to your car wash if you do that. So really they have to wash 167 cars in order to raise their $500. And if we were going to put that into a sentence, that's exactly what we would say. The chess club needs to wash 167 cars to raise $500. Okay, example 3 is comparing your height and your younger sister. Now, you may or may not have a younger sister, but let's pretend. So you are 65 inches tall. And that may or may not be true, but let's just pretend. So visualize that. You are 65 inches tall. You are also 18 inches taller than your younger sister. So that means you're taller than your sister. She's shorter than you. What is your sister's height? Now you can probably get an answer really quick to this one. But again, we want to go through each of these steps so that you can see how we make a verbal and an algebraic model to get our answer. So you have your height and your sister's height. And since you are taller than your sister, if you took your height and subtracted your sister's height, you would get the difference. You would get how much taller you are than your sister. You could also do your height minus the difference equals your sister. You could do that as well. That would also be completely correct. You minus the difference equals the sister. Okay, so I'm just going to abbreviate that. So that's another way that you could do this problem. And as we go through these, you might realize that you do a problem one way and somebody else does it a different way, but you get the same answer. That's okay. So I'm going to use the first verbal model with the big boxes to finish the problem. We know that you are 65 inches tall. So I'm going to substitute in the 65. The difference between your heights is 18 inches. Okay, so we don't know your sister's height. So we have your height is 65 minus your sister's height, and that has to equal those 18 inches. Now, if you're doing it the other way, you could do 65 minus 18 equals S. And that's probably the mental math that you did in your head to get the answer, okay? And that's essentially what we're going to do to solve this problem, okay? We're going to have to take 65 and subtract the 18 from it so we get your sister's height. So your sister is going to be 47 inches tall. And you could say that as a sentence. You could say, my younger sister is 47 inches tall. Okay, example 4. We're going to kick it up just a little bit here. A baseball team's standing is based on their win-loss record. So if you like baseball, you follow baseball, even if you don't really watch a lot of baseball, I hope you can realize that how well a team does depends on how many games they've won or lost. Their winning percentage is calculated by dividing the number of wins by the total number of games they've played. So this sentence here is actually telling us an equation that we're going to use to set up our problem. So if the team's percentage is 0.850 and they've played 80 games, how many games have they won? So what do we know? We know right here we have this sentence to make an equation, to make our verbal model. We know the team's percentage, and we know how many games they've played. So what do we want to find? We want to find how many games they've won. So to write my verbal model, I'm going to look back at this sentence here. It says the winning percentage is calculated by. Okay, so the winning percentage, I'm just going to abbreviate that as percent. The percentage is calculated by, so the percentage equals, you divide their number of wins by the total number of games they've played. So wins divided by the total games. Well, that was nice. That problem gave us pretty much a sentence that we could translate piece by piece to come up with our verbal model. So now for my algebraic model, I'm going to substitute in what I know. I know the percentage is 0.850 or 0.85. We don't know how many games they've won, so I'll just call that W. But we do know they've played 80 games total. So now to solve this, I don't really want to guess, gee, what number do I have to divide by 80 to get 0.85? Okay, whatever number that was, when I divided it by 80, I got 0.85. So what I'm going to do is I'm going to take 0.85 and I'm going to multiply it by 80 to get my number of wins. And that will get me 68 games. So if you wanted to write your answer as a complete sentence, you would say the baseball team won 68 games. Okay, so now we're going to try and do some multi-step problems. And this is really the level of algebra that we need you to be comfortable with and working at. All of the problems that we've done in the past, the first 4, those have been pretty much one-step problems. You're subtracting or multiplying or dividing. Now we're going to see problems where we have to maybe do 2 little steps to get our answer. Okay? So 5, 6, and 7 are going to be examples of that type where you have to do more than one step. So for example 5, you are responsible for buying hamburger rolls for an upcoming picnic. Okay, so visualize that. You're having a picnic at your house. Your mom says, hey, I need you to go to the store and get hamburger buns. Okay, so each bag of rolls costs $1.30. That's pretty good. That's pretty cheap for the hamburger rolls. So you are a smart shopper. And each bag contains 8 rolls. You need to buy a total of 64 rolls. How much money is it going to cost you? So again, what do we know? We know that you need to buy the hamburger buns. Okay. You need to know the cost per bag, and you need to know your total cost. You need to know how many bags you need to buy. Okay. You can't buy individual rolls. So let's see. If I was shopping, I would take the cost per bag, and I would multiply it by the number of bags that I bought. And that would tell me how much I spent altogether on the hamburgers, or the hamburger buns, or the hamburger rolls. So it seems fairly straightforward writing this equation. It's just a multiplication equation. And we know the cost of each bag of rolls is $1.30 because you're a good shopper. You found them for a bargain price. But how many bags did you buy? So let's go back to our problem. It says you need to buy a total of 64 rolls, and each bag contains 8 rolls. So basically, we have to do a little extra step here. We have to take 64, the total number we need, and we have to divide it by 8. If we need 64 rolls and there's 8 rolls in a bag, dividing 64 by 8 will tell us how many bags we need. And then once we know that, then we can find our total cost. So really, once I do this extra little division step, then I'll be able to calculate my answer. So I'll have 130, or I'm sorry, 1.30 times 64 divided by 8 is 8. I need 8 bags of rolls. So then I take 130 times 8, do that on your calculator, and you will have spent a total of $10.40. You can just leave your answer labeled as dollars. Remember, the dollar sign goes in front. If you wanted to write this as a complete sentence, you would say, I need $10.40 in order to buy all of the rolls for the picnic. Okay, example 6. You and some friends are going out to eat. Yay! I'm sure you have a lot of experience with that, going out with your friends and grabbing something to eat. You order several $5 pizzas. It doesn't say how many, there's several. But it does tell us they're $5 each. So maybe you went to Little Caesars. So your bill, when you get your bill, is $47.39. Holy cow, that's a lot of pizza. But the bill also includes tax. It includes $2.39 tax. So that's pretty cheap, actually. That's a pretty cheap tax. Okay. So how many pizzas did you get? Now, obviously, you would know how many pizzas you got if you're eating out. Maybe not, though. Maybe you're in a really big group and you didn't do the ordering, so maybe you don't know. But when you're eating out, okay, if you're calculating your price, we know that you would take the cost of the pizza times the number of the pizzas. So the cost of the pizza times the number of pizzas that you ordered. That'll tell you how much you spent on just the pizza. But your bill also includes tax. So you have the cost of the pizza plus the tax that got added on. And all of that together, that's your total bill that came. So now do you see the two steps in this equation? We've got multiplication and we've got addition. So let's start substituting in some stuff that we know. We know the cost of the pizza is $5. We don't know how many pizzas we got though, so I'll just call that P. We know that our tax is $2.39. And we know that we spent $47.39. Actually, you don't need that dollar sign in there. I just wrote that because I was looking at it in the problem. Okay? So now, if you were actually going to calculate this, you can still use a little bit of mental math here. Okay? If you want to know how many pizzas you bought, you have to know how much you spent on just the pizzas. So we've got to take our total and we've got to subtract the tax. We've got to subtract that $2.39 off of there. Okay? So $5 per pizza, after I subtract the tax off of the total, gets me $45. That's how much we spent on just the pizzas. And now that's a pretty easy problem to solve. 5 times something equals 45. Well, the number of pizzas we had to get then was 9. 5 times 9 is 45. So you ordered 9 pizzas for you and all your friends. So hopefully there was a bunch of you that went out to eat, because if there's only a few of you, you guys are really, really hungry and you can really pack away the pizza. Okay, last one. This is going to be another two-step problem, just like our previous example. Okay, your fundraising group earns 25 cents for each soda and 50 cents for each taco that is sold. So we don't know what you're raising money for, but you're selling pop and you're selling tacos, and you get a certain amount for each one that you sell. Now you do know that 100 tacos were sold, and you know your total profits was $100. So there's a lot of stuff that's being sold. And we want to know how many sodas there are that were sold altogether. That's what we want to know. Okay? So we know that there are sodas and there are tacos. We know that you have a certain price for each taco and a certain price for each soda. And you have a total amount of money at the end. So that's how we're going to set up our verbal model. We're going to have the price of the taco times the number of tacos. And then you would add that to the price for each soda times the number of sodas that you sold. Sodas that you sold. And if you added those amounts together, then you get the total that you raised. Having issues writing here. There we go. Total. So this is kind of like example 6. You're taking the price times the amount, but you've got 2 little multiplications that you're doing and then 1 addition that you're doing as well. So it's a 2 or maybe even a 3-step problem, depending on how you want to think about it. So now I'm going to substitute in what I know. I know each taco cost me 50 cents. So 0.5, or it didn't cost me, I raised 50 cents for each taco. And do I know the number of tacos that were sold? Yes, I do. 100 tacos were sold. So 50 cents times 100. And we'll be able to calculate that in a moment. I'm just going to keep substituting for now. The price that I earned for each soda is 25 cents, so 0.25 plus, oops, I'm sorry, times, we don't know the number of sodas. So I'll use N for soda. But I do know I raised a total of $100. So now let's simplify this a little bit. Let's take that 50 cents times 100. So that's $50. So we earned $50 just by selling the tacos. And I'm going to simplify this a little bit. 25 times N equals 100. Now, I just want to know the number of sodas that were sold. I know I've got this $50 over here, and I've got this $100 over here. Okay, so if I take away that $50 that I earned from the tacos, take it off here, that means I have 0.25 times the number of sodas. And just selling the sodas, I would have raised $50. I got half my money from the tacos and half my money from the sodas. That's pretty good. And now I can divide to figure out the number. I can take 50 and I can divide it by 0.25. Now remember, when you divide by a decimal, you're going to get a larger answer. So we actually end up getting 200. 200 sodas. That's how many sodas you sold. So maybe you had some people coming up and just getting a pop. Okay, you sold twice as many sodas as you did tacos. We're not really going to analyze why you sold more pop than you did tacos. Maybe they were really small or something. Doesn't matter. Okay, the point is we know the number now. We know that you sold 200 sodas. So tonight's homework isn't out of the book. Tonight's homework is a worksheet. So hopefully you grabbed one of those in class. And you can write right on the worksheet and show all your work. But follow this model. Try and write the verbal and then the algebraic and then use the mental math. So try and follow those 3 steps and use these examples as a guide. These examples will help you. There are ones very, very similar to this on your worksheet. If you have questions, come on in before school and see me.